All right. Chapter 4 review, part 2. We're on page 121, question number 11. It says, write an equation in slope-intercept form for the line containing the 2 points. It's amazing how many people will do 11 and 12 and not know how to do 9 and 10, or how many people will do 9 and 10 and don't know how to do 11 and 12. They're exactly the same thing. If you know how to do 9 and 10, you should know how to do 11 and 12. What are we trying to find if we're going to write an equation in slope-intercept form? What are we trying to find if y-intercept and slope? So we want to find the slope. How do you find the slope? Change in y over change in x. Now we could just look up. We could look up here and say, okay, with the mic working. And we can see that the change in y is a of 3. And we could just look up there and see that the change in a 2 and put 3 over 2. Or we can run the drill of how to find change. How do you calculate change? Y minus y sub 1 over slope times x minus x sub 1. So what's the y of my first point? Of my second, 9. X of my first point, my second, 5. So I'm going to have 6 minus 9, which is negative 3, over 3 minus 5, which is negative 2. What do we not like about the way the slope is written? It has a negative in the denominator, so we say our sign rules for division. When you multiply or divide with the same sign, the answer is positive, so we get a positive 3 over 2. Which is what we would have gotten if we just simply looked at the change in y3 over the change in x2. Any questions on how we found the slope? Yes. Makes no difference as long as you show your work. You can do it the calculation method, or you can just do it like that. Do it like that, do it like that, as long as you show your work. You can't just write the answer, because you know that's not acceptable on my test. All right, the y-intercept is a value of y when? Do either one of these points have an x of 0? No, so the y-intercept is not given. If it's not given, we have to calculate it. How do you calculate the y-intercept? You use 1 point and the slope. You have 2 options at this point. You could plug it into y equal mx plus b, or y minus y equals slope times x minus x. And so we're just going to do it the way we originally did it, y equal mx plus b. We're going to pick a point, 3, 6. The slope we came up with, 3 over 2, and substitute those in. This is the xy of our point, and slope is m. So we put the y of the point in place of y6, slope m in place of slope m, x of the point 3 in place of x, 3 over 1 plus b. Let's see, we got that so far. And so we're going to cross reduce, but it won't. So we just multiply, we get 9 over 2. 9 divided by 2, it'll go 4 times, you get 8. With 1 left over, you can put your remainder over your divisor, or you can add a decimal and a 0 and divide, and get 4.5 or 4.5, whichever you prefer. If it's a repeating decimal, we don't take repeating decimals. You have to write it as a fraction. And so we have 6 is equal to When we did this, we got 4.5, so we get 4.5 plus b. See, we got that? Now we're going to get the junk off of b, so we subtract 4.5. We're isolating the b. And so we get the y-intercept b is 1.5. So we have found the y-intercept, and we have found the slope. So now we can write an equation in slope-intercept form. My slope-intercept form then is y equal, what goes next? Slope 3 over 2 times x. What goes next? Y-intercept plus 1.5, or as an improper fraction, it would have been 3 over 2, just like the slope. Any questions on number 11? Understand that? Now don't forget to always be looking for constant x's or constant y's, because I might slip one of those in there and you have a horizontal or vertical line. So be looking for those. You know I'm going to try that. Oh, it is one of those. I didn't look at it close enough. Any questions on number 11? Number 12 is one of those, isn't it? So do we do all this stuff on number 12? No. You just look at it closely and you say, hey, that's got a constant y. And if it's got a constant y, then the equation is y equal the constant y. So the answer is y equals 6 to number 12. Any questions on that? You can study this concept on page 96 at the bottom, or page 97 at the top, or page 104 at the top, if you don't remember your horizontal and vertical stuff. You can see this drill that we just ran on page 101 of the textbook, and also page 97A, example 12, I think. Any questions on this so far? Through number 12, everybody understand it so far? All right, number 13. We're trying to go from, what form is this in? Standard to slope-intercept. And what is slope-intercept? Y equal mx plus b. To go from standard to slope-intercept, what's our first move? Get the x term to the other side, because we need our x on the other side. Remembering to change the sign when you cross over. And so we get 5y equal what? 3x plus 25. You cannot add those because they're like terms, so we write out the right side as an expression. It's still not in slope-intercept form because we need an isolated y, so we need to get rid of the multiplication by division. When you multiply something to or divide something by a sum or difference, you put that sum or difference in parentheses and distribute. Rule 2, page 37. Don't forget that what we're distributing is division, not multiplication. We're undoing multiplication by division. And so we get y equal 3 divide 5, which is 0.6, but we prefer to leave it as a fraction because we're not scared of them, and that is our slope, which means to go up 3 right 5, so we kind of like it to be a fraction. And then we divide 25 divided by 5 is 5, and that is our y-intercept. We have gone from standard form to slope-intercept form. Any questions on number 13? Number 14. Number 14, we have y minus 7 is equal to negative 3 times x plus 4. This is in what form? Point slope. This is a part of your rules test memory work. To go from point slope form to slope intercept form, you distribute and then undo the y sub 1 thing. Distribute and undo the y sub 1. Which one do you do first? You distribute first because you do before you undo. So you're going to get negative 3 times x is negative 3x, and negative 3 times 4 is negative, so we put a minus 12. And then we undo, because we need an isolated y, a minus 7 with a plus 7. And so we get y equal negative 3x minus 5. That's a negative. That's a positive. When you add or subtract with different signs, subtract and take the larger sign. Sign rules, page 18. What page does it tell us how to do this stuff on? Page 107. It actually has the rules for going from point slope to slope intercept on 104, and then we did it on 107 also. Any questions on going from those forms into slope intercept form? Okay. Page 122. Find the range of y equal 3x plus 2 if the domain is 1, 2, 3, 4. The range is the set of y values. The domain is the set of x values. To find the range with a given domain, we build a table like the ones that we've been building, except we plug in the x's given instead of making up our own. That's quoting page 110, I think. Is that correct? Page 110, domain and range. 109, sorry. It's 109. 110 to 110A is the homework. Now we're quoting page 97A. To build a table, we start with x because it is the domain or the independent variable. We solve for y because it is the range or the dependent variable. What we put in said y was equal to was 3x plus 2. Everybody see how we got our table started? So we plug in the domain. We're going to have 3 times my x of 1 plus 2, 3 times my x of 2 plus 2, 3 times my x of 3 plus 2, 3 times my x of 4 plus 2. Inside here we use the order of operations. We're going to do multiplication before addition. 3 times 1 is 3 plus 2 is 5. 3 times 2 is 3 times 2 is 6 plus 2 is 7. 3 times 3 is 9 plus 2 is 11. 3 times 2 is 6 plus 2 is, that again. 3 times 2 is 6 plus 2 is 8. Maybe that's why it cut out on me. I was lying and it didn't want me to lie. 3 times 3 is 9 plus 2 is 11. 3 times 4 is 12 plus 2 is 14. We're going to write our range in solution set brackets. On a test, this is not acceptable because you didn't even try to make solution set brackets. If you just throw parentheses down there, we want you to make an attempt to make solution set brackets. When you write your answer in solution set brackets, your answers must be in order from least to greatest, the way they would appear on a number line. Any questions on number 15? Finding the range of a function with the domain given. Yes?
So there's only going to be one, it's going to be the same,
The test is the same length, same format as this. Just changing up the numbers. Correct. Number 16. Now we're getting into parameter changes. You find the rules for this on page 111 through 112. They're also on page 97. That's where we learned them first. A shift or translation affects what part of the slope-intercept form of a line? It affects the y-intercept. So something is going to happen to the y-intercept. It translated down, so what's happening to the y-intercept? Increase or decrease? It decreases. By how much? 7. We want the equation of the new line, and so we're going to start with the original, y equal negative 2x plus 3. Which of those two numbers represents our y-intercept? The plus 3. We're going to do what the translation means. It means to decrease the y-intercept by 7. So my new equation is y equal negative 2x minus 4. Any questions on number 16? Parameter changes. Yes, sir. Minus a negative is a positive. If you put plus a negative, that's okay. But minus a negative is a positive. Any questions so far? Number 17, word problems involving linear equations, page 114 and 115. But we're really going to do it like page 42, number 4. I'm sorry, page 41, number 4. Remember on your homework, page 119, what we finally was trying to get to was skip all that, name the y-intercept, y-character, x-intercept, x character and all that, and just go right straight to characters of the story. And what do we put on our word sentence line? Y equal b plus mx, because we've made y equal b plus mx a formula word that fits right into page 40. Step 3, B, formula words, word sentences to be formula words. Yes?
on number 16, what do we format the y equals negative 2x plus 3?
Number 16 was page 111 to 112. 111 to 112. It's also on page 97. There's more stuff about that later on page 132, 135, and 136 that we're going to get to later. Okay, number 17. Amy's swimming pool has 80 gallons of water in it. Bing, 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 bing. What's that? Y-intercept is what she started with. We're thinking, hey, that sounds like a y-intercept thing because that's what she started with. It may or may not be, but our brain said that. And it is fitting at a rate of, there's a little typo, 8 gallons per minute. Rate of blah per blah. Ding, 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 ding. Blah per blah. Slope. Rate of change. Slope. We've got a slope and a y-intercept. That's a y equal b plus mx. How are we going to handle that now that we're past that preliminary finding our characters? This is a word problem. So what are we going to put on our paper first? Characters. We're going to quote page 40. To do a word problem, you read and understand the story. You identify the character or characters of the story and assign a variable to each one. Then you're going to write out word sentences, which could be A, comparison between two characters, B, formula words like perimeter, area, volume, circumference, etc., or C, sentences containing words like total, sum, difference, product, quotient, same. That whole page 37 list. Now, formula words. Let's talk about those. We're going to review, because this is a review. We got perimeter, area, volume, circumference, etc. Anybody know the number of them we got out of chapter 3? 7. Can you name them? Just off the top of your head, the 7 formula words from chapter 3. See how good we can do. Sum of the angles of a triangle is 180. Complementary. Supplementary. There's 3. The percent ones, what are they? Don't look. New price equal. Original plus increase. New price equal. Original minus decrease. The very first percent problem. Part equal percent times whole, and there's one more. It's on page 66. Average. 7 of them. 7 words, formula words from chapter 3. How many formula words have we pulled out of chapter 4? Slope-intercept form, y equal b plus mx, standard and point slope. What's the only one we've applied to word problems? Y equal b plus mx. So right now, as far as word problems are concerned, the only one we've added to our formula word list is y equal b plus mx. So when we see in a word problem a y-intercept, what we started with, and a rate of change slope, we know that we're going to write on our formula word a y equal b plus mx, and we're going to write the equation in y equal b plus mx form of that. So what is my y equal b plus mx equation for what I have highlighted? Gallons equal, so I'm going to write a character here. Gallons in Amy's pool. Remember, I get my characters from my word sentences. Equal. What she started with. 80. She gaining or losing? It's filling. It's filling. She's gaining at a rate of 8 gallons per minute. There's another character. Minutes of filling time. Y equal b plus mx, a formula word. But see what we're doing? We got 2 word sentences. We got 2 characters. We need more word sentences, right? So we got to keep reading. Jill's swimming pool has 370 gallons. Ding, 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 ding. That's Jill's y-intercept. Because it's what she started with in her pool. And it is draining at a rate of 12 gallons a minute. Ding, 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 ding. That's her slope. which is her blah per blah, gallons per minute. We have a slope and y-intercept for Jill. That's another y equal b plus mx. We didn't call them y equal b plus mx's on page 41 because we didn't know what y equal b plus mx was on page 41. So we did it a little different because we didn't know this. So let's write an equation for Jill's gallons. We better assign a variable, hadn't we? Gallons in Jill's pool. And we'll just call that J. So, what's my equation? J, number of gallons in Jill's pool is equal to what she started with, which is the y-intercept 70. She gaining or losing? 370. Little bitty pool. 370. It's draining. She gaining or losing? Losing minus slope. 12 gallons every minute. They say we got that? Now how many variables do we have? 3. How many word sentences? 2. We need some more stuff. Got to have the same number of word sentences, equations as you do variables. And so we keep reading. What we've found so far were formula words. Y equal b plus mx. It says in how many minutes will the pool have the same? It's highlighted so you won't miss it. What is that, an A, B, or C? C. Sentences containing words like total, sum, difference, product, etc. Same is a part of that, right? Page 37. What does same mean? Equal. When will they have the same amount of water in the pool? When will the number of gallons that Amy has, why did we call her G? That was weird. The number of gallons that Amy has, we should have called it A if we're going to call Jill J, right? Sorry about that. So the number of gallons that Amy has, A, needs to be equal to the number of gallons that Jamie has, J. Jill has J. Can't get my people straight. Now, what does it say on page 42? To be able to do the order of operations, you can only have one variable or one name. If you have more than one, you must name one in terms of the other. That's one in terms of the other. A y equal b plus mx is one in terms of the other. And substitute. So we're going to replace A with 80 plus 8m. We've got J in terms of m. We're going to replace J with that and get 370 minus 12m. By substituting, we're down to one variable m, which is what we're trying to find. The number of minutes that it's going to take for them to have the same amount of water in their pools. Everybody see how we got that? Yes.
What would you do? Would you move the minutes over first?
Yes.
Or the
Yeah.
minutes to the left?
Doesn't matter. Doesn't matter if you move your variable to the left or to the right. So what we're going to do is say, okay, according to the order of operations horseshoe, I'm going to do anything I can to simplify first. Can you simplify the expression on the left? Nope. Can you simplify the expression on the right? No. At the bottom of the horseshoe, page 33, it says, get the variable that you're isolating on one side of the equal sign, remembering to change the sign when you cross over. And so we're going to have 80 plus 20m is equal to 370. There's nothing else you can do. The variable's on one side, so it is time to undo. We're going to undo addition by subtraction. We get 20m is equal to 290. Undo multiplication by division, and we get m is equal to 14.5. So in 14 and a half minutes, they will have the same amount of water in their pools. Now, we want to go to the graphing calculator here because we want to continue to show that. And I've been fighting for time to show you calculator stuff. So what we're going to do is finish this one and go back and do a couple other things on the calculator that I haven't shown you that I really need a place to put it. And this is a good time. Okay? So we're going to go to the calculator. We're going to make sure it's cleared out. Second plus 7, 1, 2, enter, clear. Second plus 7, 1, 2, enter, clear. I'm going to go to my large screen. We're going to go to y equal, and we're going to put in the equations. So we're going to start with Amy's pool. What was hers? I forget. 80 plus 8, and we have to use the variable x, and there's our variable button, right? I'm in y equal. In the second one, I'm going to put Jill's, which was 370 minus 12m, which is, we're going to have to hit the variable button x. We want the window to fit the data. So we hit our window button. My x is the number of minutes. We know how long it took, 14 and a half, but if we didn't know, we would just make a guess. So we're just going to go 20 on the minimum 0, on the maximum 20. The scale is fine at 1. What does y represent? It represents gallons. What's the minimum gallons? One of them's draining theirs, so they're going to get down to 0. If they weren't, neither one of them would get to 0 if they were both filling them. But I do have a minimum of 0 because one of them's draining theirs, and the other one of them had 370 gallons in it, so let's just go over that some. Just make it 500. The scale could be 50 on that, or you just leave it 1, not a big deal here. We got our equations in y equal, our window fit data, so we should be able to graph and see those. The first one is Jill is Amy because she started out with less water. She's increasing. Jill started out with more and she's decreasing. Where is it that it's happening from here to here? Who has the most right there? In the red. Has the most. Amy has the least. After that point, Amy has the most and Jill has the least. And what's happening right there at the point of intersection? They have exactly the same amount. If we could get the calculator to give us the point of intersection, it would give us how long it would take. What can we do to find the point of intersection? We're going to hit second trace, which is calculate. Second trace, which is calculate. I'm going to get there in a minute. Second trace, which is calculate. I finally made it. We want to go down to number 5, which is intersect, and hit enter. It says first curve. We want to tell it the two curves. If you got something in Y1, Y2, Y3, you have to tell it which two you want. We want Y1, so we hit enter. The second curve I want what's in Y2. Yes, so I hit enter. It says over. It says guess, so I toggle over about to the point of intersection. You don't have to do that if it only hits in one point. And you hit enter, and it gives us the exact point of intersection. In 14 and a half minutes, they will both have 196 gallons in their pool. Any questions on that? We could also look at our table. If we look at a table, we can hit second graph, and we can find out where my y's are the same. If I go down, they're getting closer and closer together. What you'll notice is that somewhere between 14 and 15 is where they passed. At this point, at 14, this one was the smaller. At 15, that one was the smaller. So somewhere between 14 and 15 is where they must have been the same. So you can kind of use your table to see that also a little bit. There's a way to get exactly there, but I'm not going to go there right now. Any questions on how to use the graphing capabilities of the calculator to see some of this stuff? Yes, sir. Yeah, there are some things about the calculator I don't know, and they're engineering type applications in calculus because I don't use some of those applications every day. To 10 watt. Oh, it'll go forever. If you keep scrolling, it'll go as long as you want to scroll, infinitely till your battery runs dead. Okay, let's go to some more stuff and show you some more calculator stuff. Now, let's go all the way back to the, well, let's just do this. How could we get the answer to number 11 on the calculator? Somebody tell me what we could do. You could put your points in your L1, L2, and do a linear regression, right? You would put 3, 5, 6, 9. Let's look. So we'll get our calculator. We're going to quit that second mode. Second mode is quit. We X'd out. We hit second plus 7, 1, 2, enter, clear. Yeah, I clear for every problem. It's just better to do that. Now we're going to go to stat. We want to here. What were the x's of my points? 3 and 5. A little touchy there, isn't it? 3, enter, 5, enter. What were the y's of my points? 6, 9. Do it in the right order. 6, enter, 9, enter. Stat, edit. Stat, edit. We put our x's in L1 or y's in L2. Now what do? Stat, to the right to calculate. Down to number 4, linear regression. Enter. It's defaulted to L1, L2, so all you have to do is hit enter. We're going to write mx plus b unless we're doing a word problem. We went to stat edit, and then we hit stat again. We arrowed to the right to calculate. You can change your slope to a fraction on your own if you want to. Any questions on that? All right, let's build a table. Did I go too fast? Everybody understand that? Stat edit, stat calculate, linear regression. Let's minimize that. Find us another problem we need. We'll go back to transparency number 2. I need number 2. We need to be at the end of it is 120. Let's say that we wanted to build a table of XY values for number 6. Now, how can we get a table? You just put it in y equal and hit table, and there they are. How could we build a table exactly like we did on paper? Well, here's what you could do. We could go to our calculator. We're going to hit second plus 7, 1, 2. Here. We're going to go to stat, edit again. In our L1, we're going to put our x's that we would choose. Let's say we chose for x -4, -2, 0, Man.
How do you delete what's in your Y1?
Just hit delete while you're on it, or clear, hit clear. On Y1 you hit clear. So I'm going to hit 2, enter, 4, enter. Remember, my slope was a half while ago, so I'm using multiples of 2, multiples of the denominator, yes sir? Go, if you don't have an L1, hit stat. Go down to setup editor. See that? Hit enter again, and it'll say done, and then hit stat again, edit, and your L1's back. There you go. Isn't that weird that you can know that mess? Anyway, okay, so what we're going to do now, y'all watch, this is very important. I'm doing this as a spreadsheet. I'm not going to stay right here. I'm going to go up here so I can write a formula. Remember we put what y is equal to in the middle? So it's like we're putting what y is equal to in the middle. So I'm going to hit the up arrow. I'm going to put my slope as a fraction. 1 divide 2. Instead of putting x, I have to put L1. I'm not in y equal, so I don't have a y and an x. I'm in my list. I'm writing list 2 as a function of list 1. That's where I put my x's, and then it was a 2, is that correct? Is that what it was? And then if you hit enter, it calculates every one of them for you, just like you would do it on your paper. Yes, sir. Got it? Everybody see how we did that? Now, if you arrow down, you add another entry, and you hit enter, it will not calculate the y that goes with it because it forgot the formula. So, I'm going to go up to the top. I'm going to hit clear and down, and it's going to clear that list out. This time when I put it in, I'm going to hit alpha plus sign, and it's going to put a quote. That's locking the formula in. And then I'm going to do my open, 1, divide, 2, close, L1 plus 2. Alpha lock is closed. Yes, ma'am. Alpha lock is closed. And then I'm going to hit enter. And then if I go down and to the left and I add another entry and hit enter, it remembers the formula. So if you wanted to remember your formula, you have to put it in alpha. Notice that it put a little lock with a key in it. See, it's locked up, so it remembers your formula. All right, any questions on that? All right, that ends the review. Test tomorrow, test Friday. Be prepared for that.